Right, here we are back again. This time we're going to be doing the temperature gauges. Okay, now these work off a Wheatstone bridge system. Okay, some of you leckies, if you've done a bit of time in the job, especially some of the avionics guys, flight systems guys, whatever, you might remember these from your basic electric training. Okay, so a Wheatstone bridge. I'm reading off a script here because this one, another one I've got to do a script with, must be getting old or something. A Wheatstone bridge is an electrical circuit used to measure an unknown electrical resistance by balancing two legs of a bridge circuit, one leg of which includes the unknown component. Right, so I'll just pull up a picture here. So there's a voltmeter in the middle. There's your resistors, 1, 2, 3, and the unknown component here. Yeah. Right. So there's your meter in the middle. Okay, so what you're trying to do is balance it out. Yeah. So you don't know what this is. So this would be calibrated. This would be a center reading meter, right? So 0 is the center. Okay, and you adjust this until that's 0, and then you read off the scale on here, and that would give you the resistance of this. Now, in the good old days, MBS, right? Vulcans, Victors, ASV 21 if you like as well, on shacks. A lot of testing was done using that system. Yeah, you set up a resistance on you had a big decade, and I mean a big decade box, and attached to that would be a meter that was center reading, or center 0 rather, and you'd select the circuit you were testing. You'd put in your set resistance, which would, if you like, be this, or rather this, yeah. And then you'd adjust this on a trimmer pot, right, to 0 this, so that this would then, yeah. You see where I'm going with this. It's a very accurate system. So the primary benefit of the circuit is its ability to provide extremely accurate measurements, right? I suppose in contrast to something basic like a simple voltage divider, where it's kind of there with that. Here you can get it spot on. Yeah, we're talking decimal points here. Okay, so a little bit of history, just a short one. The Wheatstone Bridge was invented by Samuel Hunter Christie in 1833, so it goes back a long way, when these old boys were experimenting with electricity, and it was improved and popularised by Sir Charles Wheatstone, which is where it gets its name, in 1843. Okay, so like I said, the way we use it here, or the way it's used on the Lancaster, is slightly different. What we have in the middle is a voltmeter that's calibrated once again, but it's not center reading, right? Or here, okay, we'll be going from 0 to 120. Now this is in degrees centigrade, so whatever this is reading in voltage resistance, I don't know, we're not interested. So what we have, okay, once again, okay, we've got 24 volts. Now these systems are really, these will work on 24, 12. They get inaccurate after about 10 volts, because I have had a play with this back at the Heritage Centre with an adjustable power supply unit. They get inaccurate up the higher ends as the voltage drops. So below about sort of 12 volts, 11 volts, the system really sort of drops off. So this is 12 volts, 24 volt system, 28 volt system. I'm thinking here Vulcans, Victors, that kind of thing, because that's the kind of aircraft I grew up with and worked with for donkey's years. So yeah, same sort of system. So what we have here, okay, this is fixed. Yeah, these two are fixed. So what we have here, this is, if you like, this is a temperature sender. So the resistance across this varies with temperature. Yeah. So as it gets hotter, the temperature changes, the resistance changes, So the balance across here changes, so the meter will move. Yeah, you'll see it when we test it with the decade box, because what we do is we replace this by the decade box down there. Okay, so another diagram. No expense spared on production on this video, I tell you. Okay, so we've got a decade box, so we know what that resistance is at a set temperature. So we put that resistance in, yeah, power it up, and it should read whatever it is. The book's down there, and it's out of reach at the moment. But yeah, say for 109 ohms, that should read 40 degrees or something like that. Yeah, and that's what we're looking for. It's ever so simple. It's really accurate. It's more or less bulletproof. Both the oil temperature gauges and the coolant temperature gauges on the Lancaster work on that system. Same for Spitfires, Hurricanes, and all the other aircraft of that era. I would think right through to yeah, reasonably recently. I'm trying to think what might have used it until the digital systems came in. Really, thermocouples, yeah, but yeah, they can be inaccurate thermocouples. These are fairly bulletproof. Simple systems, once again, analog. None of your digital bollocks. It's what you see is what you get. Yeah, the slightest voltage. You know, if your aircraft voltage system suddenly dies and your batteries, you know, your aircraft batteries are dying, and you're on your last legs, yeah, this draws very little power to start with, and because there's no other components in the mix, you know, you're not getting any voltage regulators or voltage dividers or microprocessors running in the background or any other shit. Yeah, it takes very little current to work this, and so like I was saying, right down to round about sort of 12 volts, 11.5 volts. So when you're coming down from 24, your battery's almost screwed by then. So yeah, and this will still work, which is what you want when you're flying home shot up to shit, isn't it? So anyway, we'll take a quick break while I reorganize things, and I'll come back and we'll have a quick look at the meter. We'll show you where the three resistors are, because those two you wouldn't think they were, and that one is plainly obvious, but you wouldn't know. You can see it, but how do you change it if you need to? Because I had noticed that that resistor is different between the coolant and the oil, basically because they're looking for different. The bulbs are the same, the temperature sensors are the same, but the gauges are slightly different. I don't have a water temp gauge here, but we do have an oil temp gauge. It's faulty, and we'll see the fault as we work on it down here. But anyway, so we'll I'll just take a quick break. Oh, excuse me. I've just had me lunch, and it's gurgling away down there. Although you possibly want to know that, but anyway, back in a mo, guys. Right then, so here we are back on the bench. So what we've got here is got 24 volt PSU, which is plugged in, ready to rock and roll. We've got a decade box, which we've spoken about. And here we have the little meter itself. So remember, the decade box is going to take place of the temperature sender or sensor, call it what you will. Okay, so the gauge reads 0 to 20 degrees in centigrade, yeah, which is quite unusual because at the time we tended to use the Fahrenheit system in this country. So maybe that's to do with the Americans coming in. I don't know. Anyway, so we're looking for. Okay, just put that on there. So on the output, let me just get the metal cover for it, and then you might be able to see if I pop the cover over it. Okay. So marked on here, you might be able to see is VR minus, plus 24, and R. Okay, so what we've got here, there's your plus 24, there's your BR minus, and there's your R. Right, so that's where the resistances are going. Just take that off. Right, so your resistors, okay, get this around the right way. You've got two there. Let me just, you've got two there, because I think the main chassis of these, a bit more light maybe, might be, yeah, you can see those two there. The black, wire wound, obviously very accurately wound. So they would be those two, right? This one here, okay, which is the one that can be replaced easily they say, yeah, is that one there, which is a long wire wound. You can't always see that on these gauges. Some gauges you can. I suppose it all depends on the age. This gauge dates from about I think on the box it said 1952, so it's a bit older than me, this one. So yeah, so there's your three resistors, one, your two wire wounds, and your potted one there. Okay, your fourth resistor is a decade box. Right, so it's fairly straightforward, isn't it? So what we'll do, so that's the circuit as we're going to wire it up. So what we'll do is I shall pop that back into its box, and then it's fairly safe. So I'll just pause this. Okay, so oh, excuse me, we've got the gauge connected to the decade box and the power supply, which is just what we've got there, right? So to test this, you can't see my table because it's just out of shot that I'm looking at in the AP, but I can see that if I put in 90 ohms here, that's 90, okay, that should give me a reading of 0 on the meter. Okay. Next one down is 100 ohms. Okay, 100 ohms should give me 20, and it does. The next reading is 109, so 109. Okay, that should give me 40. Now, where we need to be accurate on this gauge is round about the 80 mark. So the next one is what we're looking for, 119. So 119. That should give me 60. Yeah, and let's see. Notice that the gauge is a little iffy now, and this is a problem we got with this particular gauge, is it's sticking. I haven't got a serviceable gauge here with me because both of them were US. One wouldn't read it well. One just read full scale deflection, and this other one, although they're new old stock, yeah, things do deteriorate over the years. So 119. The next one is 129. 129. That should give me 80. Once again, it's still sticking. And the real fun starts when we get above there. Right, so turn it off. 140 now. 140 should show us 100, and it does. Okay, turn it off, but it stays there, and that's the problem we've got with this meter. Yeah, it sticks. 151 is the next one. 151. That should be 120, which it is. Okay, so if I bring this down now to say 109, 109. Yeah, now that should be reading 40, but it's not until we tap it. but it's not shifting at all. There we go. Yeah, so this meter is definitely toast, or it needs expertise. I always think there's, I've had a look at the mechanism because it's a standard moving coil meter. I've looked at the mechanism and I think there's a bit of corrosion somewhere in the mechanism itself. But I can't get to it. It needs a specialist instrument, if you like, a horologist, someone who's into very fine mechanisms. I'm afraid my eyesight won't do it these days. So yeah, so there's the basics of it anyway. So it's fairly straightforward, isn't it? Analog. Instead of using a variable resistance to work out, if you like we were with the Wheatstone bridge, if you didn't know what that resistance was, you could vary that one to adjust that, to zero that, and that would then, you could measure that and that would be that. Yeah, because they're balanced arms, if you like. But in this instance, we're varying this to give us a reading on this, an accurate reading, I might add, not just any old reading. So yeah, so it's a very, very simple system, very accurate, almost bulletproof. The only thing that's going to go wrong is the moving coil mechanism in the meter. And it's not a happy teddy, that, so I'll go back up to 140. Yeah, and that's way over. That's gone way over. And if we, yeah, there we go. It's back down to 100 now. So yeah, so it's not a happy teddy, that, which is why it's got a red label on it with my stamp on it to say it's it needs to go somewhere to be serviced, because I do have my limits here. So yeah, so that was easy, wasn't it? That was a fairly quick one. Yeah. So right, well. We'll just readjust for the final bit. So hang in with me. Right, well, that's about it then from the workshop for now. The next one might be motorcycle related, I don't know, because I've now run out of stuff to test. I had a huge box here of bits and pieces. But I only videoed the things that I thought you might be interested. So yeah, I mean we've done the gauges, we've done the desins. I know I did some short videos over the Heritage Centre about it, but I thought I'd do it in a bit more depth, might make it a bit more interesting for you. So yeah, yeah, I hope you enjoyed it all. Like I say, I don't know when I'll get another one done. Yeah, anyway, before I waffle on and bore you all to tears, I'll say, yeah, all the best, guys. Take it easy, stay safe out there, and I'll see you again on the other side. Bye for now.